5 workbook questions. Question 10. A choice is fair if all blank one of concern have a blank of occurring. Match each numbered blank to the answer that correctly satisfies the corresponding blank in the previous sentence. I know that blank 2 is going to be equal probability, because to be fair, you have to have an equal probability of having it. So now we need to talk about, is it the sample space that needs to be equal outcomes or the event? Sample space is everything that happened, so all of the trials, the total number. So that's not blank one, because it doesn't make sense. A choice is fair if the total number of trials had equal probability. No. So then we're going to go to outcomes. A choice is fair if all the outcomes of concern have an equal probability of occurring. Well, the outcomes are, did you have a heads or did you have a tails? That is the outcome. The outcomes are heads or tail. Now the event is having the coin be heads. That's the event. So the outcomes are the options, heads or tails, and the event is I want heads to happen. So that's the specific thing that happens, and it needs to be that a choice is fair if all of your events of concern have an equal probability. And I would write this down in my notes as a definition. Okay, question 9. Your friend has a bag full of candies. Each piece of candy is one of these colors: green, blue, red, yellow, or orange. You randomly pull out 3 candies to see which colors come out, and then you replace the candies and try again, repeating the experiment a total of 15 times. The outcome of each trial is listed in the table below, where G means green, B means blue, R means red, Y means yellow, and O means orange. Match each event to the corresponding experimental probability. Okay, so our first event is pulling exactly one green piece of candy. So I'm going to go through, and since each of these boxes represents an event, I'm going to go through and find the ones and count the ones that only have one green. So event 1 had 1 green, event 6 only had 1 green, event 8 only had 1 green, event 11 only had 1 green, and that is as far as I could tell. So for the probability of having 1 green, it's going to equal 4, because there was 4 events that happened out of 15 total trials. So I'm looking for 4/15ths. Alright, pulling exactly 2 green pieces of candy. So I'm going to go through again and count each experiment, each event that has 2 green candies. So event, let's see, event 12 has exactly 2. Event 13 has exactly 2. So probability of exactly 2 green candies is going to equal 2 times. It happened twice out of 15 of the trials. So I'm looking for 2/15ths. There it is. Okay, the next question is pulling exactly 3 green pieces of candy. So I'm going to go through and count how many times having all green happened, and I see it once and no other times. So the probability of 3 green is going to equal 1 time out of the 15. So it's happening 1/15. Pulling at least 1 green piece of candy. Okay, so probability of at least 1 So that means that I could have one green, I could have two greens, or I could have three greens. And because if I pull two greens, that's at least one. So at least means that it has to be greater than or equal to that number. So at least means that it has to be greater than, I drew that symbol backwards. It has to be greater than or equal to that number. So that is what at least means. So I'm going to go through and count. I would include that in your notes as well. At least means that anything bigger than that number, and at most means anything less than that number, including that number. So let's go back through and count where 1, 2, or 3 greens happen. So we have 1 green there, 3 greens, 1 green, that's at least 1, that's at least 1, that is at least 1, event 12 is at least 1 because it has 2, event 13 is at least 1 because it has 2 green. So now we're going to come over here and copy. So the probability of having at least 1 green is going to happen 1, 2, 3, 4, 5, 6, 7 out of 15 times. So I'm looking for 7/15. Alright, and let's check that. Great job. Alright, let's go on to question 8. You flip a fair coin 10 times. The outcome of each trial is listed in the table below where H means heads and T means tails. What is the experimental probability of the outcome being heads? Okay, so the probability of being heads is going to equal how many times did the event occur, so how many times did heads happen. So it happened once, twice, 3, 4, 5, 6, 7. It happened 7 times. And it happened, and there's a total of 10 trials, so that's our sample space. So it happened 7/10 of the time, or 70% of the time. Great job. Okay, you roll a standard 6-sided die 3 times. What is the probability that you roll a 1 exactly twice? Okay, so I think of my sample space as, well, I have 3 rolls. And my first roll, I have 6 options, the numbers 1 through 6. On my second roll, I still have 6 options, the numbers 1 through 6. And on my third roll, I have 6 options still, 1 through 6. And I want to find out how many times the event where I roll a 1 exactly twice is. So now this is a combination because it doesn't matter whether I roll the 1 in the first position, the second position, or the third position, as long as I have 2 of those 1s. So we have 6 choices, we have 6 numbers, and we're going to choose 2 because we want that number 1 twice. We want it repeated. So we're going to go to our combinations calculator, and we're going to go to Google, and this is how I got here. I typed in combination calculator, and it was the first one that popped up, combinations calculator, NCR calculator soup. So then I'm going to type in 6 as our objects, and our sample space is 2. So we're going to calculate, and it is 15. So this equals 15. And what is 6 times 6 times 6? And I just went to our regular calculator on Google. 6 times 6 times 6. That's 216. So the probability of pulling a 1 twice is going to equal 15 out of 216. So we have 15 out of 216, and we're going to submit that for grading. There we go. Alright, so now moving on to question 6. You flip a fair coin 8 times. What is the probability that the coin lands with heads side up exactly 6 out of the 8 times? Okay, so then I'm thinking of the same thing. What is my sample space? What is the number of outcomes we could have? And I flip a fair coin 8 times. So on the first roll, I have 2 options. On the first roll, I have 2 options, heads or tails. The second flip, I have 2 options, heads or tails. The third, I have 2 options, heads or tails. The fourth, 2 options, heads or tails. The fifth is 2 options, heads or tails. The sixth is 2 options. The seventh and the 8th time is 2 options. So this is going to equal 2 to the 8th. And you go over to your Google calculator, you hit 2, the x to the y, and 8. And that equals 256. So our sample space is 256 different outcomes, or different events, different outcomes. And then how many different ways can we have our event happen? We want exactly 6 times out of the 8. So we have 8 of our rolls, and we're going to choose 6 of them because we want only the ones that have 6 heads up. So go back to your combinations calculator. 8, choose 6. We're going to calculate that, and it comes out to be 28. And so then we're going to come over to our course player, and our probability of heads happening exactly 6 out of the 8 times is 28 out of 256. So then we're going to look for 28 out of 256. There we go. Question 5. A total of 10 students are entered in a drawing to win 3 identical prizes. A group of students is composed of 6 boys and 4 girls. What is the probability that 2 boys and 1 girl win prizes? Okay, so they want to know what is the probability that 2 boys and 1 girl win prizes. So we need to find out, well, what's our sample space? So how many different ways can I choose? There's 1, 2, 3. How many different ways can I choose 3 identical prizes out of the 10 students? Or how many different ways can I choose 3 students to win the prizes out of the group of 10? So this is going to be 10 students, and I'm choosing 3 of them. Okay, and then what is the probability that 2 boys and 1 girl win a prize? Okay, well, out of 6 boys, I need to choose 2 of them. So I'm going to have 6 choose 2 for the boys, and so multiply 1 girl, or out of 4 girls, I have to choose one of them. So then we're going to come over to our combinations calculator, and we're going to type in 6, choose 2, calculate that. That is 15. That's going to equal that's going to equal 15 times, well, what is 4? Choose one. That's 4. So 15 times 4 divided by, what is 10? Choose 3. 10, choose 3. Calculate that. That's 120. Okay, so then I'm going to, what is 15 times 4? That's going to, oh, not 43. That's going to equal 60. So 60 out of 120, or that's 1/2. So we're looking for a 1/2, and I see 1/2 right there. So I'm going to select that and submit for grading. Okay, great job. So when we're finding the probability of things that are grouped together, so like 2 out of the 6 boys or 1 out of the 4 girls, we're going to use combinations. So then let's move on to question 4. You have 7 books on your shelf. You notice that 3 of them are written by author A and 4 of them are written by author B. If you choose 3 books from your shelf at random, what is the probability that 2 will be by author B and 1 will be by author A? So I want the probability that 2 are from B and 1 is from A. So my first question is, how many different ways can I select 3 books? Because I want to choose 3 of them. Okay, if I choose 3 books, how many different ways can I choose 3 books out of 7 total? So I'm going to have 7 choose 3. That's the total number of different ways I can select those books. And then for the event, I want 2 to be by author B. So I look at author B. He wrote 4 of them. So out of 4 that author B wrote, I want to choose 2. And I want 1 to be by author A, and I look and author A wrote 3. So out of the 3, I'm going to choose 1 of them. So then we're going to go back to our combinations. We're going to do 4 choose 2. That's 6. So we have 6 times, and 3 choose 1. This is our author from author A. So that's 3, and that's going to be divided by, what is 7 choose 3? That's going to be 35. So then, what is 6 times 3? Well, that's 18 divided by 35. Okay, so now I'm going to go to the course player, and I am looking for 18 divided by 35, which is right there. So my answer is just already in simplest form. Let's make sure. Great job. Okay, so again, you're combining your options. So these are all how many different combinations can you make out of that group. And the reason why on the flip a fair coin 8 times, that's because each one of those, it's the same coin. So that's why we did 2 times 2 times 2, and that's because you have a head or a tails each time. So moving on to question 3. A mother is driving her 4 children, Alejandro, Diego, Marie, Anna and Amelia to the library, and all of the children want to sit in the front passenger seat. The mother decides to design an experiment that will produce a fair decision. Okay, fair decision means everyone has an equal amount, the same amount, equal opportunity to win. So, method 1, in a standard deck of 52 playing cards, Alejandro is assigned cards with the heart suit, Diego is assigned cards with the diamond suit, Mariana is assigned cards with the club suit, and Emilia is assigned cards with the spade suit. One card is drawn at random, and the child whose suit is chosen gets to sit in the front seat. Well, since each suit has the same number of cards in it, and each kid is given an individual suit, that means they have the same number of cards out of all of those 52. So that is fair because they have 1/4 of a chance, or 25% of a chance being chosen. So method 2. On a standard 6-sided die, Alejandro is assigned the numbers 1 and 2. So that's 2 out of the 6 numbers. Diego is assigned the numbers 3 and 4, so that's 2 out of the 6 numbers. Mariana is assigned number 5. Okay, I'm going to stop right there because Mariana already has one less number, so that's unfair. So it is unfair because Alejandro and Diego each have a third chance of being chosen. Where did they get the third? That is because 2 out of 6, 2 of the numbers out of the 6 choices reduces down to 1/3. So that's where they found the 1/3 from. Then method 3, Alejandro is assigned the numbers 1 through 25, Diego is assigned the numbers 26 through 50, and Mariana is assigned the numbers 51 to 75. One number, okay, pause. Where is Emilia? So that's unfair because she doesn't have a choice. So let's select those. Great job. Okay, question 2. 3 friends are trying to choose a restaurant for dinner. Benedict wants Pizza Palace, Chandra wants Pasta and More, and Ada wants Burger Barn. They decide to design an experiment that will ensure a fair decision as to which restaurant they will choose. So on a standard 6-sided die, Benedict is assigned the numbers 1 and 2, Chandra is assigned the numbers 3 and 4, and Ada is assigned the numbers 5 and 6. Since they all have the same they are all assigned 2 numbers out of those 6, so it's fair because the probability of each person being chosen is 1/3. 2 out of 6 again is 1/3. So on a fair coin, Benedict is assigned heads and Ada is assigned tails. Well, I'm saying unfair because Chandra doesn't have is not represented. Okay, so then in a standard deck of 52 playing cards, Benedict is assigned the cards with clubs and spades. Okay, so he's assigned half of them. Chandra is assigned the cards with the diamond suit. I'm stopping right there because Chandra is assigned only 1 suit where Benedict was assigned 2. So it's unfair because the probability of Chandra being chosen is 50%. Nope, Benedict's 50% because he was assigned 2 suits and 2 of the suits is 50%. So the others were only assigned 1, which is 25% of the cards. Okay, and question 1. The spinner below is divided into 6 sections. There are 2 sections, each of the colors blue, green, and red. You decide to spin the spinner 20 times and record which color it lands on each time. The outcomes of each trial is listed in the listed in the table below, where R means red, G means green, and B means blue. The experimental probability of spinning a red is, okay, well, how many times did you spin a red? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They spun it 11 times out of the 20. So I'm looking for 11/20ths. So blank one is 11 out of 20. All right. Next, you decide to increase the number of trials. When 200 trials are performed, the spinner stops on red 60 times. When 2,000 trials are performed, the spinner stops on red 662 times. When 20,000 trials are performed, the spinner stops on red 6,667 times. Using this information, you conclude that the theoretical probability of the spinner will land on red is blank. Okay, well, we're going to use the one that has the most number of trials. So we have 20,000 trials, because the more trials you have, the closer it is to the theoretical probability. So that's why we're using the outcomes with the most number of trials. So it happened 6,667 times. So now I'm going to jump to my calculator and type in 6,667 times divided by 20,000. That's going to equal 0.33. So it's approximately 0.33 or 33.3%. So blank 2 is the closest to a third. Well, what is a third? Okay, so we are having an off day, or I just don't know what a third is as a decimal. Well, what's 1 divided by 3? 0.33. All right, that looks the closest. So there we have it. And let's check, make sure our work is correct. Great job.